Today we are doing Notes 1.5a, Limits for Infinite. Determine the limit of each function as x approaches 1 from the left and the right. As we can see from the graph, as x approaches 1 from the left, it's going up towards positive infinity, and as x approaches 1 from the right, it's also going up towards positive infinity. So the limit as x approaches 1 of the function 1 over x minus 1 squared is positive infinity. We could check this too if we were to make a table for ourselves to be able to kind of see what's going on here. If we're looking at what's happening on either side of 1, so if we kind of put a 1 in the middle here, and then we say, let's do 1.9, 1.5, 2, and then maybe we'll do 0.9, 0.5, and 0. If we were to plug in 0, 1 over 0 minus 1 would just be 1. 1 over 0.5 minus 1, well, that's a half. A half squared would be a fourth. So we'd have 1 over 1/4, which we could flip around, and that would actually give us 4. 0.9, we could do 1 over 0.9 minus 1, which would just be 0.1, which is the same thing as 1/10. So we flip that, we get 10. And then this would be like our undefined one. But the same thing's going to happen. 1.9 minus 1 is 0.9. So we're also going to get 10, 4, and 1. So you can see those numbers like are pushing themselves up towards positive infinity on that side. Our other function here is negative 1 over x minus 1. And we can look at the picture here. The limit as x goes to 1 from the left is going to be positive infinity. The limit as x goes to 1 from the right is going to be negative infinity. And we could draw a table for this to kind of explain it as well. If we had 0, 0.5, I'm just getting close to 1 there so we can get an idea of what's going on. And we could do 1.09 or 1.01, 1.5, and then even go to 2 per se. So if we plug in 0, negative 1 over 0 minus 1 would be negative 1 over negative 1, which is just 1. What about negative 1 over 0.5 minus 1? Well, it's going to be negative 1 over negative 1/2, which is going to be positive 2. What about 0.9? Negative 1 over 0.9 minus 1 would be negative 1 over negative 0.1, which would be this, which would make this come flip up to a positive 10. So we can see that that's going towards positive infinity as we approach 1. This would be undefined because 1 minus 1 is 0 there. What about here when we're getting into the 1.01? Well, we could do negative 1 over 1.01 minus 1, which is going to be negative 1 over 0.01, which is exactly what we did over here. So again, this one is 10. But look, this one doesn't have the negative there, so it's actually negative 10. And so if we do negative 1 over 1.5 minus 1, I'm just plugging these into the equation. I do negative 1 divided by 0.5. Again, we have the same fraction, but this one's positive and a negative, so that actually makes a negative 2. And then the same thing's going to happen with our 2 that happened with our 0. Negative 1 over 2 minus 1 is negative 1 over 1, which would make that the negative example there. So you can see that this is pointing down and this is pointing up as we're going towards 1. So the definition of a vertical asymptote, this is something that you've learned for a long time, but now we're going to understand like a little bit more of a practical definition of it. If f of x approaches infinity or negative infinity as x approaches c from the right or left, then the line x equals c is the vertical asymptote of the graph of f. So you've seen vertical asymptotes, and really what that's saying is that our graph is approaching infinity or negative infinity from our limit from the left to the right. So our theorem says, let f and g be continuous on an open interval. So remember, continuous, no holes, no jumps, no gaps. If f of c does not equal 0, g of c has to equal 0. And there exists an open interval containing c such that g of x does not equal 0 for all x does not equal 0 in the interval. Then the graph of the function has a vertical asymptote at x equals c. So what does this mean? So it's saying if we have a point in our function f that does not equal 0, and g does equal 0 at that point, then there exists an open interval for c where like it's saying if this equals 0 and this doesn't, we can't cancel them out. So it's not a whole. So it's going to actually be a vertical asymptote. For example, if we had x plus 2 over x minus 4, this equals, when this is 4, that equals 0, but up top it doesn't. So this would be a vertical asymptote at x equals 4. However, if we had something like this, maybe we had this, at x equals 2, we know that this equals 0, but it does here too. So this one is no vertical asymptote because they can cancel off, and that's just a whole. So that's like a little bit more from pre-calc in a sense, but now we're using the limit terminology. Okay, so let's look at our picture here for A. We want to look at these and find the vertical asymptotes for them. So for this one, we have the denominator 2 times x plus 1. So that when x equals -1, that's when we have a vertical asymptote. And let's see, does the numerator equal, can we plug -1 in to cancel that out? No, we can't. So by theorem 1.14 that we just saw, x equals -1 is a vertical asymptote. Okay, let's look at the next one. X squared minus 1. Where does that equal 0? Well, we can factor it. We're looking at the denominator here. X plus 1, x minus 1. So at x equals -1 and at x equals 1, we have our potential candidates for the vertical asymptote. But let's look at the numerator here and see what happens. X squared plus 1. We have that, can we factor x squared plus 1? Not to get anything real. And so that's not going to cancel out. So this is also our vertical asymptotes here. And we can use that theorem to conclude that if the denominator equals 0 at those points and the numerator does not, then it's a vertical asymptote. Okay, for cotangent of x, let's write it as cosine x over sine x. We can see where sine of x equals 0. Let's see where that happens. Let's look at our unit circle. So we know we have this, 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 and this. So where is sine 0? Cosine comma sine, right here at 0, and right here at pi. Does this happen for cosine? Is cosine 0 at any of those points? No, it doesn't. So we know that at every pi value, at x equals pi n, because every pi that we hit around the circle, there will be a vertical asymptote where n is an integer. Okay, next one, determine all the vertical asymptotes of the graph. So all that we have to do for this is to start factoring. What multiplies to give -8 and adds to give 2? -4, or +4 and -2. For this one, what multiplies to give -4 and adds to give 0? -2 and +2. So does anything cancel off? Yes. So we know at x equals 2, that is not a vertical asymptote. But at x equals -2, when we solve this one, that is a vertical asymptote. And so we can see that this is where our vertical asymptote is. All right, find each limit. So we're looking for the limit as x goes to 1 from the left and the limit as x goes to 1 from the right. So we can start by looking at where's the vertical asymptote, because that's synonymous with limit. So for this one, we know the vertical asymptote is at x equals 1. Does that cancel off? No. So vertical asymptote is at x equals 1. Vertical asymptote is at x equals 1. So this means that our limit is either going to be positive infinity or negative infinity. It's just a matter of determining which one. We could use the graphing utility to look at which way it was going, or we could just look at some of the values as we plug them in. Let's try a couple of values as we get close to this 1. So if we have 1, we could have 0.9, 1.01, and then maybe we'll do 1.5 and 0.5 just to kind of see what's going on. If we plug this in to our graph, we have 0.5 squared minus 3 times 0.5 all over 0.5 minus 1. I can just plug this in. to my calculator. And in fact, I could actually just type it in and do it into a table. So I'm going to do that because that'll be faster. X squared minus 3x over x minus 1. Oops, I need my parentheses. X minus 1. Second table up here. And now I could actually plug in 0.5. What do I get? 2.5. What am I at 0.9? 18.9. And then what about 1.01? I'm at negative 201. Wow. And at 1.5, I am at negative 4.5. So what do you think? As we're coming this way, we're going down towards a negative infinity. And as we're going this way, we're coming up towards positive infinity. So we would write this as the limit as x goes to 1 to the left is going to be infinity, and the limit as x goes to 1 from the right is going to be negative infinity. We could also double check, put it in our graph, actually graph it. Let's see what happens at 1 from the left, positive infinity, from the right, negative infinity. Awesome work.